All right, so today we're going to continue our notes from about inverse functions. So theorem 5.8 says continuity and differentiability of inverse functions. So we're supposed to let f be a function whose domain is an interval I. If f has an inverse function, then the following statements are true. If f is continuous on its domain, then f inverse is continuous on its domain. If f is increasing on its domain, then f inverse is increasing on its domain. If f is decreasing on its domain, then f inverse is decreasing on its domain. And if f is differentiable at c and f prime of c does not equal 0, then f inverse is differentiable at f of c. So, theorem 5.9 tells us that the derivative of an inverse function says let f be a function that is differentiable on an interval I. If f has an inverse function g, then g is differentiable at any x for which f prime of g of x does not equal 0. Moreover, g prime of x equals 1 over f prime of g of x, where f prime of g of x does not equal 0. So remember, g is the inverse function. So we are going to graph the inverse function f of x equals x cubed and g of x equals x to the 1/3, and then calculate the slope of f at 1, 1, 2, 8, and 3, 7, and the slope of g at 1, 1, 8, 2, and 27, 3. And what do you observe? So first thing I'm going to do is I'm going to graph the two inverse functions. So I will get out my calculator, see if I can get this so there's no glare. There we go. So I will graph x cubed and then it says graph x to the 1/3 and calculate the slope of f So for f, to find the slope, that would be the first derivative, so that would be 3x squared. So f prime of 1, 3 times 1 squared would be 3. F prime of 2 would be 3 times 2 squared, which would be 12. And then f prime of 3, which would be 3 times 3 squared, which would be 27. And then we have to find the slope of g at 1, 1, 8, 2, and 27, 3. So g prime of x would equal 1/3 x to the negative 2/3. So that would be the same thing as 1/3, 1 over 3 x to the 2/3. So g prime of 1 would be 1 over 3 times 1 to the 2/3, which would just be 1/3. G prime of 8 would be 1 over 3 times 8 to the 2/3, which would be 1/12. And then g prime of 27 equals 1 over 3 times 27 to the 2/3, which would be 1/27. And what do you notice about these? How do they compare? So you're right, it would be the reciprocal. And then what would happen at 0, 0? If I look at the graph, so at 0, 0, we would have a horizontal tangent line or a vertical tangent line, right? So for example 5, we're supposed to let f of x equal 1/4 x cubed plus x minus 1. And they want to know what is the value of f inverse of x when x equals 3. So essentially they're wanting us to find the f inverse of 3. And they want to know what does this equal. Now remember, our relationship between the original function and the inverse function is where they flip-flop the x and the y. So if this is an x value in the inverse function, then that means that really in my original function would be the y value. So they're saying the y value is 3. So we want to find out what is the x value. So what I'll do is I'll set 1/4 x cubed plus x minus 1 equal to 3. And then to solve for x, since this is x cubed, I can't really factor this. So I'm going to go back to my calculator and I'm going to graph these. So I will graph 1/4 x cubed plus x minus 1, oops, plus x minus 1, and then I will also graph f of x equals 3. And I want to find out where do these two functions cross, where do they intersect. So I'll go menu, analyze graph, intersection, and it wants to be on the left side, lower bound, upper bound. Basically it wants to know what's the section you want it to look at. And so it looks like my x value would be 2 when my y value is 3. So this means x would be 2. So I know f inverse of 3 then would equal 2. So then for part B, it wants us to find the value of f inverse prime of x when x equals 3. So remember, f inverse prime of x, according to our derivative here, is 1 over f prime of, remember they use g of x instead of f inverse of x. So in our case, we want to know 1 over f prime of f inverse of 3, which we found in part A. F inverse of 3 is just 2. So I have 1 over f prime of 2. So to find f prime, I haven't done that yet, so I'll do that up here. So f prime of x would be 3/4 x squared plus 1. So to find f prime of 2, I just have to plug 2 in there. So I get 3/4 times 2 squared plus 1. And this would give me 4. So I get 1 over 4. For example 6, it says let f of x equal x squared for x is greater than or equal to 0, and let f inverse of x equal the square root of x. Show that the slopes of the graphs of f and f inverse are reciprocals at each of the following points. So I will go ahead and find the derivative of each of these functions since they gave me what the functions were. So I know the derivative of x squared would be 2x, and the derivative of f inverse, this would be, remember this is the same thing as x to the 1/2. So I'd have 1/2 x to the negative 1/2, or 1 over 2 square root x. So I want to show that they're reciprocals of each other. So this goes in for f, this goes in for f inverse. So f prime of 2 would equal 2 times 2, which is 4. And then f inverse prime of 4 would be 1 over 2 square root of 4. Well, the square root of 4 is 2, so I get 1 over 2 times 2, which is just 1/4. And these are reciprocals. So then for part B, same function, but this time we're using different points. We're using 3, 9, and 9, 3. So remember we had for f prime of x was 2x, and f inverse prime of x we had as 1 over 2 square root of x. So if I plug in 3 into f prime, I get 2 times 3, which is 6. And if I plug in 9 into f inverse prime, I get 1 over 2 times the square root of 9. So that would be 1 over 2 times 3, which would be 1 over 6. And these are reciprocals of each other. So that's it for today. You can use the rest of the hour to work on our homework, which is 5.3, page 347, numbers 24 to 42 even, 48 to 60 even, and 72 to 90 even.